Right, welcome everyone to our topic 9 just-in-time math PD session. The pair deck is in the chat, so you can jump on. This session is being recorded, just for your information. And I believe Michelle has the pair deck, and then we're going to start with our territorial acknowledgement. So I was thinking about multiplication and division, and about the scenarios in which people are sharing something or things are growing and multiplying. And I began to ask myself, okay, how does this maybe connect to a tradition of our Indigenous people? And right away, the idea of the dish with one spoon came to mind. So the dish with one spoon is a treaty between the Anishinaabe, Mississauga, and Haudenosaunee that bound them to share the territory and protect the land. And subsequent Indigenous nations and peoples, European settlers and newcomers have been invited into this treaty in the spirit of peace, friendship, and respect. So according to the Haudenosaunee, the concept originated many hundreds of years ago and contributed greatly to the creation of the Great League of Peace, which is between the Haudenosaunee Confederacy, the Iroquois Confederacy, made up of the Seneca, Cayuga, Oneida, Onondaga, and the Mohawk Nation. So I got to dig a little bit into the history of this concept, and particularly where this dish was considered. So this bowl or this dish represents what is now Southern Ontario, from the Great Lakes to Quebec, from Lake Simcoe to the US border. So the idea is that we all eat out of this dish. All of us that share this territory with one spoon only. That means that we have to share the responsibility of ensuring the dish is never empty, which includes taking care of the land and the creatures we share it with. Importantly, there's indicated that, it's interesting that there's no knives present at this table. This represents that we must keep the peace. The dish is graphically represented by also the wampum belt that is pictured in this slide. I'm going to give you an opportunity to listen to Richard Hill, a Six Nations community historian from our local area, and what he has to say about this dish in this video that we're going to watch together.
So the idea was that this beautiful earth was given to us. It's like a dish. And inside that dish are everything that is there for us to be healthy and to be fed. So all the plants, the animals, the birds. And the concept was we're all going to share from the dish with the same spoon. Everybody gets their equal share. Everybody gets an opportunity to take that. So it's about sharing the resources of this land. But in order to share it, there's some simple rules. One is you only take what you need right now, feed yourself, make yourself well. You always leave something in the dish for other people so they can enjoy that as well. And you keep the dish clean. You don't pollute your kitchen. You don't pollute where the food comes from. Only recently, in the last few years, have the Anishinaabe people and the Haudenosaunee people said, let's get back to this sharing. Let's get back to this idea. So we're working very hard to recover. What is our notion of the great dish, the dish with one spoon? Why is it important that we share? It's got to do with hunting, fishing, and gathering, but it's also got to do with a healthy frame of mind. That maybe inside that dish, what nature provides is healthier for us than what the supermarkets provide. Maybe what's inside this dish will help us be stronger Indigenous people. So that's why we're trying to explore that. Maybe the dish will even help us recover from colonization and residential school trauma. My name is Rick Hill. I'm a Tuscarora. We follow our mother's side of the family. My dad's a Mohawk, but my mother's a Tuscarora. We're here.
I just wanted him to introduce himself there. All right, so that video is actually really interesting. It goes on for the next 12 minutes or so. So if you have time, it's linked there. You can watch it. It's really good background information for me that was new as well. So it's really cool. So with this in mind, we'd like to begin by acknowledging that the land on which we gather today is the traditional lands used by the Haudenosaunee, Anishinaabe, and Neutral people. We also acknowledge the enduring presence and deep traditional knowledge, laws, and philosophies of the Indigenous people with whom we share this land today. Okay, so today's agenda is we're going to look at revising timing with our April break. That's the March break being shuffled. We're going to look at topic 9, the LRP site, and some of the overview of the curriculum. And then we're going to get into models and strategies for multiplication and models and strategies for division, and have some time for Q&A at the end.
Hebron, we still see the territorial acknowledgement slide.
Oh.
There we go.
Oh, wait, you know what? Here. I've got 2 different versions.
Yes, I know.
Okay, so thank you. So that's our agenda. Again, revised timing, topic 9 curriculum, models and strategies for multiplication and division, and Q&A. So here's an opportunity for us to, in the pair deck, share which topic are you currently on. This is something that we've been gathering data as we go along with our just-in-time sessions to be responsive. So I'll give you just a couple minutes, and if you could just select which one of those topics you're on. And we've tried to cover the bases, and if it's something other than that, it's okay. You don't have to worry about it.
As Hebron said, it helps us to know when we should be planning so that we are still just in time, because that's our goal, is to be right when you need the PD.
Absolutely. All right. So let's keep, hopefully that was enough time. Let's keep going. So looking at the revised timing with the April break. So you'll notice that the order of the topics does not change. We have provided a calendar overview on the LRP homepage that'll give you a bit more of a specific view of those dates beyond the main landing page for the grades that you're used to so far, which have also been updated. This is available on the LRP homepage. One of the things we're going to note is that topic 9, which is today's just-in-time session, is occurring just before the March break would have been and during the March break. So those are the 10 instructional days for that. If you have any questions about that, we will give you maybe a little bit of time to clarify any things that might come up. It's actually quite nicely laid out on the home page of the LRP site. All right, so we're going to get into the topic 9 multiplication and division concepts here by jumping into the curriculum expectations. So these next couple of slides are just going to give us the text overview of the expectations that are addressed in topic 9 that are related to multiplication and division. They are broken down into the topics of properties and relationships, math facts, mental math. And in the next slide, we'll see that we've got multiplication and division expectations as well. These are, we're not going to speak to the text slides particularly as much because we wanted to have a visual continuum that is basically all the information in those 2 text slides that are straight from the digital curriculum site, presented in a way that maybe in one snapshot might be a little bit easier to grasp. So I'm going to take a few minutes to just speak to the growth of concepts across junior and give us kind of insight into where students are coming from in primary. You'll see that in primary, in the property section, which is the top half of our visual here, that students are engaging with, representing and describing. Particularly, they're engaging with the connections between various specific operations. In junior, they're engaging with multiplication and division across 4, 5, and 6. In the properties of these 2 operations and the relationships between these 2 operations. Again, when you're thinking big picture, we are transitioning students in primary from thinking additively to thinking multiplicatively in grade 4, 5, and 6. You see some of those facts growing. In grade 4, they're doing mental math facts of 10 by 10, dividing by 10, and doing some multiplication of 10, 100,000 and dividing by 10. In grade 5, it's growing to 12 by 12 and dividing by 12, dealing with some mental math multiplication of decimal tenths and hundredths, and some estimation with decimal thousands. In grade 6, they're jumping to some divisibility rules, dealing with more of factors and composite numbers we'll see in the operations section. And they're dealing with the concept of percents, doing mental estimation of percents of simple chunks like 1, 5, 10, 15, 25, and 50%. And we see in the operations section underneath in blue that grade 4 starts off with multiplication. They're working with up to, starts with 2 to 3 digit numbers by 1 digit number, and by that idea of which connects to the mental math piece of multiplying by 10, 100,000. The multiplication in grade 5 grows to 2 by 2 digit whole numbers. They're working with area models and algorithms at this point. And then grade 6, they're dealing with composite numbers and prime factors and multiplying and dividing 3 digit numbers by decimal tenths. I'm going to go down to look at division a bit. In grade 4, division is 2 to 3 digit by 1 digit, very similar to grade 5, but they are dealing with remainders here and representing remainders as fractions, which we'll see as we engage in some of the models and strategies later. And in grade 5, 3 digit by 2 digit division, whole numbers as well. So that kind of gives you a progression overview of what the operations look like as they go from grade 4, 5, and 6. It's important to note that your students are coming at varied places along this continuum. So this is a good place to kind of be able to look and reference where are students coming from and where am I taking them to. Even if I'm working with grade 6 students, doesn't mean they're coming in with particularly grade 5 or grade 6 level on that continuum. So it's good to pay attention to that. All right. Now I'm just going to hand it over to Michelle to talk to us about number talks.
Thank you. One thing I really want to highlight that Hebron mentioned, because we only have 1 hour, that's quite short. So we have a specific focus today on models and strategies, but multiplicative thinking really is crucial and is developing across junior and even into the intermediate grades. So we can only address so much in this hour, but just know that that whole idea of multiplicative thinking is crucial as students progress. So some of the expectations across the junior grades that can be addressed in number talks and are best addressed in number talks are those ones that focus on mental math and the math facts. So you can see in grade 4, multiplying whole numbers by 10, 100, and 1,000 and dividing by 10 you can easily do some number talks that will get at that. Similarly with the grade 5, multiplying by 1/10 and 100th, and in grade 6, multiplying by tenths and 100ths again, and also divisibility rules. So that piece in grade 6, the multiply by tenths and hundredths, isn't explicit in the curriculum. It's implied that they understand it from grade 5, but we know, especially for this year, that our students currently in grade 6 have not had a lot of experience multiplying whole numbers by decimals. And so giving them those opportunities through number talks. And some of the resources for these number talks include the Fosno resource, Mini Lessons for Extending Multiplication and Division, the Parrish book called Number Talks, and then some of the Math Up number talks. Although Hebron and I were talking, and they're not quite as effective in terms of developing the properties of numbers that we want students to develop. So the other two resources are better. And there's just an example on that slide as well. So our focus, as we mentioned, is models and strategies, thinking about multiplication. In grade 4, ideally, we want students to have concrete, be able to build concrete arrays with things like color tiles. In the distance learning environment, that might be more of a virtual, but the idea is that we want them to be able to manipulate and rearrange arrays so that they can explore and understand some of the properties of multiplication. For example, that 5x4 array, when I rearrange it into a 4x5 array, it's still the same number of tiles. The area remains the same. The product of those two numbers is the same. Similarly, looking at the yellow and red one, having students explore concretely and visually helps them to see that 5 times 7 is the same as a 5 times 5 plus another 5 times 2. The best way to get at this is through some context. And the link there to the Weebly site, there are a lot of images there that have context. A lot of them are food context, so I intentionally chose non-food context. But we want students to see these arrays in lots of different contexts and to experience these arrays to help build that understanding and get them to be thinking multiplicatively, because they're not, the more exposure they have to arrays, the more they're going to start doing that grouping. Instead of thinking additively, they're going to be unitizing, and they're going to be looking at that whole row of 4 hydrometers or electricity meters. And so other contexts as well, candies in a box, seating in a gym, cars in a parking lot, anything that's going to be arranged in rows and columns is going to help students to understand and be able to think multiplicatively by unitizing those groups. So in grade 4, lots of concrete and visual with contexts that support arrays. On to grade 5. We're still thinking in terms of arrays, but by grade 5, we hope students have had lots of experience with the concrete arrays or the visual arrays that are filled in. And now we want to get into the open arrays. So what we'd like to do on this slide is a waterfall strategy. And for those of you that are not familiar, waterfall strategy, we're going to do it for each of A, B, C, and D. So you're going to think about that letter A right now and what number is missing where the letter A currently is. And the way the waterfall strategy works is you're going to type it into the chat, but you're not going to press enter or return. I will count down, and I'll count down from 3, and then I'll say waterfall. And at that point, everybody presses enter or return, and then we'll see the kinds of answers we get. Just an aside about the waterfall strategy, it gives students processing time, and it invites more students to participate than if I just ask for one person's answer. So type in, what do you think the value of the box that's labeled A should be? And 3, 2, 1, waterfall. Okay, so I'm seeing some 10s and some 20s. Now I would like to invite somebody to unmute and volunteer to justify your answer of 10 or 20. Do I have a volunteer? Emily, I see you unmuted. Go ahead.
Oh, lucky me. I was thinking in terms of like a fact family. I know that 50 times something has to be 1,000. So I know that I can do 1,000 divided by 50, and that will give me the missing piece, which is 20.
Okay, so Emily, you're showing me that you have an understanding already of that array, that you're recognizing that that 1,000 in the middle is the product of the 50 on the left and the box that's labeled A. So already I've made some assumptions about your understanding of this array. So 50 times 20 gives us that 1,000. Okay, we're gonna do the same thing for B. So type your answer in, don't press return for the box labeled B, or the cell part of the array labeled B. And 3, 2, 1, waterfall. And we have all kinds of answers that say 400. So I'm just going to fill in the blank for that one because we know the 50. We knew the 50 times 20, which was A. So 50 times 8 is the 400. We're going to do the same thing for C. So for C, you're typing in your answer, but don't press return yet. In 3, 2, 1, waterfall. Okay, this one I'm going to invite somebody else to unmute because there's a lot of blanks. How did you know what C was? So do I have another volunteer? Wendy, go ahead.
I knew that 8 times C would get me 32, so I knew my facts and I knew that 8 times 4 was 32.
Okay, thank you. So
And I double checked that I was really right, just in case I wasn't.
good for you. That's the other nice thing about the waterfalls. You can check after. You get immediate feedback if you agree with your colleagues. So we can see that sometimes you have to look further for the information that's going to allow you to solve. And then we're not going to go ahead and do D because it's the same process. But in grade 5, we're still using a visual to help students understand. And the open array in particular helps to make connections, which we'll see in a couple of slides, to an algorithmic way of solving this same multiplication problem. So some context that help you look at open arrays, similar to the visual arrays that we had in grade 4, seating, a wall tile or pattern or mosaic art where we've got certain sections a certain color. And then things like an organizer. So if you imagine a sewing kit or a fishing tackle box, you might know that there's, you know, the tackle box is like a 50 centimeters by something, and then there's another piece. And so helping students by thinking about those kinds of contexts where they can visualize a tackle box or a sewing kit or something else that is an organizer. Okay, on to grade 6. Thanks, Hebron. Grade 6, we're continuing with that idea of open arrays, but the big difference for grade 6 is now we're multiplying by tenths. And we don't want to jump to some trick where we say, oh, you just, you know, count, or what we do want to do is have students think. So in this particular array, we can see that if I multiply 300 by 9, I get 2,700. So I can ignore the decimal for the sake of multiplying, but now I have to actually think about what makes sense. So 300 times 9 is 2,700, but I don't have 9. I have 9/10. And I can think about 9/10 being close to 1. So if I multiply 300 times 1, it's 300, but I'm just shy of multiplying by 1. So I know it has to be just less than 300. And that helps me to place the decimal. So the key is we want to make sense of it. We don't want to just blindly place a decimal by counting some random numbers. We want to make sense of the answer. And as I was trying to think about different contexts, it's not particularly easy. The grade 6 curriculum is specifically 3-digit whole numbers multiplied by tenths. So finding context is a little bit tricky. Painting a mural, so you've got a mural on a wall, it's 9/10 of a meter high, the space, and it's 365, it's a really long wall, meters long. And so, you know, how much area do we have to paint? Similarly, mowing a really long, narrow, maybe it's better for, but 9/10 is not very wide for crops. Anyway, it is a bit challenging to think of context. And but you want to at least begin by introducing context to help students visualize and think about what that looks like. And then you can move away from the context and get into just the mathematics, which leads us to the next slide. It's really important that students have those visual models to connect in their brains with the algorithmic, the symbols, the symbolic math that we do want students to know. We don't want students drawing pictures all the way through their junior years to solve multiplication problems. So if you look at the grade 4, I talked a little bit about this on the slide. We want to make connections for students between that visual and then some of the properties of multiplication. So the commutative property, we know that 5 rows of 7 is the same as 7 columns of 5. The distributive property, where if we distribute the 7, so we have the 5, we distribute it across 5 and 2, so we break up our 7. We can see that. And so helping students to see that connection. in grade 5, the partial product algorithm is a really efficient and effective algorithm and can be the end goal. It doesn't have to be the standard algorithm that we learned as kids, because it's just as quick, and we're dealing with place value numbers. So we're multiplying 4 times 8, then we're multiplying 50 times 8, 4 times 20, 50 times 20. So we're actually making more sense of it. And connecting that to the array helps students to see all of those partial products, all of those pieces that make the final product. Similarly, in grade 6, we can again use a partial product algorithm where we kind of don't pay attention to the decimal as we multiply. Then at the end, what product makes sense? If I'm thinking about 9/10, since again it's close to 1, my answer should be close to 365, and I'm able to place my decimal in the answer based on making sense. Okay, so at this point, I'm going to hand it back to Hebron, who's going to get you to do some problem solving. Hebron, you're muted.
Thank you. All right, I'm going to read you this situation. Mr. B's grade 5 class collected food items last year. Each student collected about the same number of items in his or her class. They collected several hundred items in total. What's going on in this problem? You can pop it into our text slide here. What's going on in this situation? Okay, so if you pop over to the screen that I'm sharing in the Google Meet tab, you can see some of people's responses about what situation this is. There's food involved, different amounts of food. There's the theme that I see happening is there's some multiplicative relationship. Growth is happening in what people are mentioning. So we're going to keep that in our back pockets, and we're going to continue. I'm going to read this again. Mr. B's grade 5 class collected food items last year. Each student collected an average of 12 items in his or her class. They collected 375 items in total. Look at the numbers in the problem. What do you notice, and what questions come to mind? So you can just unmute and share or pop in the chat. What do you notice about the numbers?
I noticed that 375 is not going to divide evenly into 12. So I'm going to get like a, I don't know, that quarter. Went to university for math, don't know that off the top of my head. But anyway, like I'm going to get like a quarter or a half kid. So then I look at the word average, and then it's like, oh, so they didn't all actually bring in 12.
That's interesting. Interesting perspective. So you can see the 375 and the 12, and there's already multiplicative relationships in your mind that you've built through your schema, perhaps, or through your experience, and no, this isn't going to match, right?
Can I ask a question,
yeah.
Emily? So you said something about half or quarter of a person. What? I don't see anything about students that would lead me to that. So what are you inferring?
I'm inferring that 375 divided by 12. So splitting those items into groups of 12, because each kid, I kind of ignored the word average. In my mind, each kid in the class brought in 12. So I was thinking if I had 375 things split into groups of 12, I would end up with one group that didn't have 12. And then, so it's like, is that half a student? Because every kid was supposed to bring in 12.
Okay, so you were thinking about like these students, you were visualizing these students and their piles of items. Thank you for sharing your thinking.
Bruce is saying it's presenting like a division question. There's some anticipation of a scenario turning into a division question. 12 is Eva. Am I saying that right, Eva? Hopefully. You correct me if I'm saying that wrong. Eva Marie. 12 is close to 10, so you can encourage the use of friendly numbers. Okay, doing some estimation ahead of time, something that's a good precursor. I'm going to read that again. If you pop over to, oh, I'm actually sharing anyway. So Mr. B's grade 5 class collected food items last year. Each student collected an average of 12 items in his/her class. They collected 375 items in total. How many students were in Mr. B's class? Use a visual model to show your thinking. So this is what we're going to do now. We're going to give you about 10 minutes. I'm going to put you in breakout groups. There is a slide linked onto here, a shared slide that you're going to be working in. You just scroll down and don't pick the master one, but scroll down and pick a spot and pop your names in and work collaboratively together on solving this problem. The goal is to use a visual model to show your thinking. Wendy, do you want to, you guys were working on some interesting visuals on slide 5. So if we all in our slide deck jump on slide 5, I believe it was Bruce and Wendy that were on there. Am I right? Or
No, Gareth and Wendy.
Gareth.
I don't know what type anything. This is my picture.
Oh, okay.
So we had our 375 things and we needed to split them into 12 groups. So we drew 12 squares. Then we started splitting up 10, 10, 10, 10, 10, 10. Then we had 120. We realized we could divvy up 10 3 times, and that ended up, we had 360. So these are my little groups of 10. Then we had 15 things left. So we put 1 in each box, and then we had 3 left over after that.
That's cool.
So, yeah.
That's so. I see some this transition from additive to multiplicative thinking. Michelle is like, in that you were, okay, this is going to take a while, right? So the students are going to start by grouping. It seems to be a very natural way to like think about division. And then you're like, okay, I got to make bigger jumps here. This is going to take forever for me to get to 375. So I see that in there. It's fantastic.
Yeah. And I found that when students start, they just make little marks, but then they can't keep track of how many marks they've made. They never think to make tallies, even though tallies would be a great idea, but they never think to do that. So then we started saying, well, why don't you just write the number 10 in there?
Excellent.
And then I find it goes to partial quotients really nicely from here.
Awesome. Oh, Bruce is here too. Perfect. Thank you, Wendy. I like that paper visual is fantastic. We are going to keep chugging on for the sake of time. There's lots of visuals in this. I thought slide 5 was really interesting. Slide 4 had some good thinking and
Can we have slide 5 explained? Because I don't know what the thinking is.
I believe Bruce and Cindy were working on that. Do one of you want to speak to that?
Cindy's is at the top.
Oh,
she was plugging away in Polypad while I was trying to use a diagram.
I'm curious about the flow chart. Where'd the 288 come from?
288?
Yeah.
144 plus 144.
Oh, so okay. Does it start at the bottom?
Yes.
Okay, and so you were okay. So why 4 groups of 12 times 6? Where did that come from?
I originally, when Emily was speaking, I originally figured that if I did 12 times 12 and then another 12 times 12, that would be two 144s, which would get me to 288. And then I figured out how much I still had to go to get to 375.
Which is how much? Is that in the visual?
That's in the notes. I put it in the notes underneath.
Oh, okay. Okay, so then you still had 87 more to go. Okay.
Yeah.
Okay, cool. Thank you. I just wanted to understand that visual. Sorry,
So
Hebron.
I'm just in grade 6, so I only know up to 12 times 12. So
That's great.
trying to
that's
figure out what I don't know by using what I do know.
Exactly.
And the connection that you made to thinking in 12s because of the divisor is interesting, right? That's great. Okay. We are going to keep moving here.
Are you going to share your screen again?
Yes. There it is. So what we just did together was called a 3-read protocol. And you'll notice that I was reading the text to you repeatedly. And what that is, it's a closed read of a complex math word problem or task. And the purpose of it is to engage students in sense-making, especially if it's language-rich mathematics. It focuses attention on the importance of understanding what's happening in this situation before we get the numbers and start doing like operations, right? Because students want to just take the numbers and do stuff with them. So it encourages that conceptual thinking and understanding what's going on. It also allows for differentiation. If you have a classroom of ELL learners or varied learners, it allows that processing time and gives them access to the problem, and so they can engage in the math. So how do we do it? First, we read it. The teacher reads it out to the students, and you'll notice that there's 3 versions of the problem. One is just the context, stripped of any of the question or the numerical values. And the second read is a reread or a partner choral read. In our case, I just read it, but it's understanding the mathematics. So reading it with under the question of what are these numbers doing? What do they mean? And then the third read is a reread, partner and choral, to elicit inquiry and questions based on the scenario and engage with the problem. So that's 3-read protocol. It's linked there for you. It's pretty great because it really emphasizes thinking for me and my students. We're going to get into some division strategies really quickly. But before we do, let's talk about these terms. So we've got the dividend, the divisor, and the quotient. So the quantity to be divided is called the dividend. So you've got a big pile usually, right? And the dividend is divided by the divisor. So that's the number of groups that you're taking that pile into. And the quotient is the result of the division problem. So this terminology is really good to go over with your students as well, to make it clear, because even if we've heard it before, it's easy with all those D's and dividend, divisor to get things mixed up. So one of the things we want to note here is we've broken things down into grades, not to say that these strategies are only useful in these grades, but to kind of emphasize the types of numbers we have in these examples. So the digits, are tailored towards grade 4, 5, and 6. But these strategies and these models are obviously useful across all grade 4, 5, and 6 grades. So here is regrouping the divisor. In this case, we take a situation that's being divided by 6, and we divide it first into 2 groups, and then we divide each of those groups into 3, knowing then that we'll have a total of 6 groups. This is a useful strategy to help us especially build fluency. So contexts for this are maybe you're sharing cookies. Those chocolate bars that come in those little tiles that perfectly break off? Maybe you're sharing one of those. Or packages of, right? There's package scenarios related to food or other things, boxes that might be good context for students to engage with for regrouping the divisor. We're going to move on to regrouping the dividend. Here we have a situation, we're splitting 48 into 8. So think of it, maybe you've got a pile of candy, 48 pieces, there's 8 people sharing it. We can take that and split the dividend to say, hey, first I'm going to take 24 and split it into 8. That'll give me 3 per person, and then another 24 and split it into 8. That'll give me another 3. Important note here is that notice that we're splitting the 24 and the 24 have to total to give you the original dividend. And the divisor, you can't, if you're regrouping the dividend, you can't also mess with the divisor. You can't do that. So just context, working with context in these strategies is really important for students to start getting those relationships. Again, same scenarios, packages, candy, and that tiled chocolate bar. Grade 5 division. We're looking here at repeated subtraction of groups or divisors. Oh.
Yeah, how come it's that?
That's so strange. Yeah. Here, let's do this instead then. There we go. Share this tab instead. All right, so there's, we've updated the slides, but the pair deck doesn't seem to want to update. We wanted to actually, I can speak to that. We wanted to update this slide because we wanted to emphasize that in grade 5 students are working with open number lines rather than closed number lines, which seems in that previous visual, that's kind of the emphasis, is that we've got a closed number line. And that's not what we want them to do. It's inefficient with the scales of numbers we're working with. So we want them to be flexible and deal with number lines that are closed. So this might be a visual representation of something that we've worked with when we're looking at our number line. And we're doing repeated subtraction, but we're not doing it one group at a time because we realize, hey, this is a big chunk. You might say 10 groups of 12, or maybe 20 groups of 12, 20 groups. That's 240. And then I can go make a jump of 10 groups, that's 120. And then I can make one jump of 12, and I'll realize that there's 3 remainder there as well. So that's one way of visualizing repeated subtraction, but thinking of it not just away from the additive sense and chunking things. This connects to what Wendy just showed us, but she was building up and doing them in groups. In grade 6 division, we've also got ratio tables. Ratio tables is a really effective strategy, which I enjoy. Here we've got the 345 divided by 7/10. Now, we're going to rewrite this situation with an equivalent division statement with a whole number divisor. So we're going to take 7/10, multiply it by 10, make it 7. In order for this equation to be equivalent, the same, we'll also have to multiply the dividend from 345 to 3,450. So if what we had grew by 10, and what we're dividing by also is 10 times, not grew by 10, is 10 times larger, and what we're dividing by is 10 times larger, the quotient should be the same. Now we're dealing with a whole number situation instead of a decimal tenth situation. This is another way of thinking about this connection in grade 6, just like making sense of it when you're done. You might do 345 divided by 7, like the example that was we looked at for multiplication. It's just another way of looking at it in a way that makes sense and it's logical, and it's not just some random rule where you're like adding a place value or something like that, you know? And using ratio tables, we build up, right? We've got groups of, we're dividing 3,450 by 7. So if we have 1 in each group, we have 7. So 10, we have 70. So, and in the bottom row here, we just keep track of what we've done relationally as we build up. So we've taken column A, we multiplied by 10, and taken column B and multiplied by 10 again to work our way up to 3,450, or as close to it as we can get. Possible context here might be distances, weights, and capacity when we're dividing by 7/10. So again, just like we do with multiplication, we're going to connect to the algorithms. When we look at the grade 4 breaking up the divisor, just, you're going to represent that in terms of numerically like that. When we jump to the numeric too quickly, students are going to start doing weird things, and I call it magic, because they're not actually conceptually understanding what's happening. They're just like, trying to put things together. So it's important that we take the time with the models and then make it numerically represented. And you see that in the repeated subtraction algorithm there, that what was done in a number line can be done as well in that algorithm, where we're taking groups of 20, 10, 1, and then having the remainder of 3 out of 12. In the ratio table, you can see the same repeated subtraction algorithm shown numerically. That's also shown in ratio table. Now in grade 6, we want to point out that the ratio table is actually more of a strategy. It's not, we wouldn't call it an algorithm, but a strategy. It's not necessarily a model because it's not visual. It's just a way of organizing our numeric steps. And now we're just going to look at your sample weeks at a glance.
Really?
Just,
you know what, Hebron, just stay on that slide. That's fine.
okay.
So those are linked. But basically, you can see that what we've tried to model, we haven't been doing this in the junior. In the grade 7 and 8, we've been providing a sample week at a glance for each topic. And the teachers have found it very helpful. The difference is that we're able to do 1 for grade 7 and 8, and here we've had to create 3. So it's a little bit more work on our part, but hopefully you're finding it valuable, because we're basically saying across a week, here are a few building fluency or number talks that you might do to get at your grades expectations. Here are a few 3-part lessons. There are some days where the 3-part lesson is either only 1 part and then you're doing some purposeful practice, or it's a shorter 3-part lesson with some purposeful practice. So take some time to check those out. What we've modeled in the session are some of the tasks right from those weeks at a glance. And they're just samples. It's not we're saying this is what you should do. We're just suggesting this might be helpful as you start to address this topic, because here's some things you can actually do with your students. Save you a little bit of planning, and then you can just be responsive to your students as you work through those weeks at a glance. Or that week at a glance, since it's only 1 grade. And we can go on to the next slide.
Oh, 2 places.
There we go. So the last slide here before we finish is just reinforcing some of the tools to support multiplication and division, because we do want it to be visual. So color tiles are a nice concrete or virtual visual. Base 10 blocks. So the website that's linked there is actually quite nice, because you can build arrays, where some of the other links, some of the other virtual base 10 blocks you can't rotate. So this one actually allows you to build it, and you can change the color of the different blocks, which is kind of nice. And then just having some grid paper. There's a link to the whole virtual manipulative list as well that has all kinds of manipulatives that you may choose to use for this and other topics. So finally, we're going to ask you to provide some feedback. What is something you're taking away from today's session in the Pear Deck? And as you do that, we're just going to give you a heads up that the next just-in-time PD, based on what, so because we hadn't received your feedback on the earlier slide yet, we were looking ahead at the analytics for the long-range plan website. And based on what we're seeing people are doing, we're anticipating that Tuesday, March 16th, should be about just in time for topic 10. So that is when we have scheduled the next math just-in-time session, Tuesday, March 16th. And again, we're going to ask that you supply, okay, I'm going to read that there, Emily, because that might
Ignore me for now.
No, so we are open for questions. So I'm going to read what you wrote now.
Mm-hmm. So
So, Emily, what I would suggest for students who get stuck with something like 3 times 9 is to decompose the 9, or 3 times 10, and then take away a group of 3. So help them to, rather than drawing it out or using their fingers, help them to use something they already know, a fact that they know. So if they know 3 times 5, and then they know 3 times 4, or they know 3 times 10, and they could take away a group of 3. And that's something I would do in a number talk. Like, actually practice that. So what are all the different ways we can multiply 3 times 9, and help give your students some of those strategies.
And it might be just, a couple of small group sessions where you look explicitly for those students from 1 to 10 and make those connections for them. Something that might be anchor charted somewhere or put in a journal or whatever that they can reference to and build their fluency, depending on how big that group is. Yeah.
I think I'm wondering, because this is my 3rd year teaching this grade now, and every year at 3 different schools to add, and every year it's the same, and it's like a large group. Like, I have 28 in my class right now, and I would say like between 14 and 15 of them, if we did 3 times 9, would be like 3, 6, 9, etc. Because they wouldn't even be comfortable skip counting by 9. They would be like, ugh, don't want to do that. So I guess I'm wondering, in terms of like putting a 12 by 12 grid in the inside cover of their duotang, I've really tried to stay away from this. But then I see, with a problem like this, like the 300 times the 9/10, I see the students that know 3 times 9, they're like, oh yeah, that's a 27, and they can make those connections. And the other ones sit and struggle to figure out 3 times 9. So would it be something positive where for everyone, if they had a 12 by 12 grid, they can quickly look, 3 times 9 is 27, and then they're able to move on to the conceptualization with the tenths? Or should I just continue to focus on the 1 by 1?
I'm going to say it's an and. So I would say yes. When I taught grade 6, I did have multiplication grid for students, and everyone had one. In fact, it was in the planner, the school planner, and they were allowed to access it. But at the same time, I continued to build fluency through number talks, so that it became for most, not all, it became for most that it was just easier to do the mental math than to go and find the multiplication grid in their planner. But you do want to have that resource as a scaffold for students, because you want them to be able to engage with the problems that have the bigger numbers without getting hung up on their multiplication facts. At the same time, you're reinforcing through building fluency, or as Hebron said, like with a whole class, or as Hebron said, using small group instruction and building fluency specifically for those students. Hebron, what did you end up using? Cindy's question.
Representing multiplication, which slide? Oh,
the algorithm, how you did the.
I just drew it in slide with a bunch of text boxes. Is it for specifically the algorithm, Cindy? Yeah.
Mm-hmm.
Yeah, where you had the long division.
Yeah, I just I can go back to it here. I just did it in slides. It's just text boxes. Actually, one text box, and then I drew lines on it. Yeah, it wasn't anything fancy.
But Equatio will, like Equatio as an add-on, it will allow you to do, maybe not the full long division.
I know it's great for fractional values.
And it's good for the question, like for the actual, just to show 3,450 divided by 7 in that format, but not for actually completing the repeated subtraction algorithm.
I would just draw it on Jamboard and use the text feature if you're self-conscious about your handwriting like I am. I would draw the lines and stuff on freehand and then use the type feature. And then if I really wanted to put it in a Google slide after, I would just screenshot it and put it in.
Yeah.
And the one in the center of this slide is actually screenshotted from the curriculum. That's right from the ministry curriculum.